Hi, this is Miss Webb. This is the last major assignment we're going to do before we would take a test. So I'm going to go over this one with you, and then I kind of put some stuff together that I had in Algebra 1, and I put it as notes and some really easy questions, and it might be something that you might want to save before you take your SAT. But today we're going to talk about using that addition rule for calculating the probability of the union of two events. And remember, union is, let me go get my pen. Well, actually, I'm going to do a highlighter. Highlighter. Okay. Remember, when we're talking about the union, we're talking about an or statement. And when we've got independent events, we're going to use the addition rule. We've actually been doing that. I'm going to show you about that. Okay, when you're talking about an and statement, both things have to be true. It's the intersection of two events, and we're going to use the multiplication rule. And then also, we can actually combine the addition and the multiplication rule for calculating probability. We'll show you that. And then they're going to talk about calculating probability for disjoint, which I have never heard of. It's a new word for me. I always use mutually exclusive events. Okay, so let's get started. I'll do this. Go over. Here we go. So the addition rule for any two events, A and B, this is the new rule for you, is if it's A or B, then you're going to add the probability and you're going to subtract the intersection of those probabilities. We actually have been doing this. When we had those Venn diagrams and you had this is P, let's say that's Q and that's R. So when we wanted to know what was the probability for A or B, we just said, oh, it's P plus Q plus R. We did that in all the previous lessons. Well, I want to show you how they really got to this formula. What they're doing is they're saying, well, if you take the probability of A, well, the probability of A is actually this whole thing, which is P plus Q. And then the probability of B, remember we put it down here, would be Q plus R. And then we would subtract off the intersection Q. Well, if you come down here, let's see, you got Q minus Q here. Those cancel. And you're left with P plus Q plus R. Okay. So that's how we ended up when we looked at the Venn diagram. We just went, oh, that's P plus Q plus R. But actually, this is what we're doing. We're taking the probability of A, the probability of B, and we're subtracting off the intersection. Let's give it a try. Okay, this one. This one, the first exercise they give you when a car is brought to a repair shop, it will need transmission fluid replaced. And so they give you this first answer, it's 0.38. The probability they'll need brake pads is 0.28. Okay, the probability will need both. It's going to need both. Transmission fluid and the brake pads, they give it to you. It's 0.16. Okay, so if you want to use the addition rule, which is when you have an or statement, what is the probability the randomly selected car needs the transmission fluid or the brake pads need to be replaced? So you're going to take the probability of the transmission, the probability of the brakes, and you were lucky they gave you that one. And I believe you get like 0.5. I know, let me get my notes out real quick, or my calculator, one or the other. Okay. And you are going to get 0.5. Okay. So that's one of the exercises. Let's try another one. Use the multiplication rule. I'm just kind of reminding you, you use multiplication for and statements or intersection statements. Use the addition rule when you're doing or statements or the union. If you can get this down, you pretty much got it. So on this one, it says Josie will soon be taking exams in math and Spanish. She estimates the probability that she passes the math exam is 0.9. Probability that she passes Spanish is 0.8. She is also willing to assume that the results of the two exams are independent. They need to be independent of each other. Just like in the car, brakes and transmission were independent. Okay, so if you use Josie's assumptions of independence and you want to calculate the probability that she passes both exams, that's like an and statement. And what are you going to do? You're going to multiply. So the probability that she passes both, okay, it's going to be 0.9 times 0.8, and you get 0.72. That's the probability that she passes both exams. It's an and statement. You use the multiplication rule. Now, if you want to find the probability that she passes at least one of them, it gives you a really nice example that the hint is at least one of these exams is the same thing as she either passes math or Spanish. And when you use or, you're going to use the addition rule. So the addition rule is the probability of what? Let's see, let me put this, at least one. You're going to take the probability that she passes math plus the probability that she passes Spanish, and you're going to subtract off the intersection, which you found up here. That's a 0.72, and you're going to get a 0.98. Do you see how you can combine the and the multiplication, but you got to get it straight on which one's used? When do you use and multiplication, or you're going to use the addition? Let's try another one, the other exercise. They're going to now talk to you about these mutually exclusive or disjoint. And they give a few examples if you have an animal hospital. So let's see, it's got 5 dogs, 3 cats, and there's 10 animals. They didn't tell you what the others are. I don't know, maybe they're raccoons or something, I don't know. And it wants to know what's the probability that an animal selected at random is a dog or a cat. Okay, well, when you would do that probability, do you notice there is no intersection between the dogs and the cats? You can't have any cat dogs in this example. So you can't be both at the same time. This next example, if you read through that, talks about, okay, so you have students and you have 3 different projects, but you cannot be working on any of them simultaneously. In other words, you're either cleaning up nearby parks, you're tutoring elementary schools, or you're going to the recreational center. But there's no overlap here. You can't do both. Okay? So in the above examples, they do not have any students in the intersection, so there's nothing in the intersection. There's nothing that has to be subtracted out. Okay? So when you're doing that probability, you're not going to subtract anything out, or if you do subtract anything out, it would be 0 because they're disjoint. They have no outcomes in common. Okay, and the Venn diagram would look like this. There's no intersection. Okay, another way of describing disjoints is by saying they cannot both happen at the same time. Okay, and you'll see that with some real life examples. Okay, here's one. It talks about if a number cube has faces numbered 1 through 6, and the number cube is rolled once, then the results is even, and the results is 5 are disjoint. Since you cannot be even and a 5, it can't happen on a single roll. But the events the results even and the results greater than 4, okay, they're not disjoint because you could get a 6 and both events occurred. So that kind of, they cannot happen at the same time is important. Okay, so normally when we have this probability of A or B, when they're mutually exclusive, it's the probability of A plus the probability of B. There's nothing here. So it's just, you add those two. And let's show you some examples with that. Okay, So this one, you have 40 cards. 10 of them are black, showing squares, 10 black showing circles, 10 red showing X's, 10 red showing diamonds. A card will be selected at random from the set. Find the probability that the card is black. Here's the OR statement. So we know we're going to do what? We're going to do the addition rule. And it shows a diamond. Okay, if it's black, can it be black and show a diamond? It cannot. These are mutually exclusive. So the probability that it's black, okay, probability that's black, well, there's 20 black cards out of the 40, plus the probability that it's a diamond, well, there's 10 out of 40 that are diamonds. So you got 3/4, 0.75, or 75%. Okay, let's try another one. Okay, now this is also another combination use of multiplication and addition rules. Okay, so let's look at it. A red cube has faces labeled 1 through 6, and a blue cube has faces labeled in the same way. The two cubes are rolled and find the probability of each event. What is the probability that both cubes show 6s? Okay, so that's the probability of the red showing a 6 and the blue shows a 6. Here, let me get rid of this. And the blue one shows a 6, right? That's an AND statement. I'm going to use my multiplication, and I get 1/36. Okay, now if the total score is at least 11, okay, let me see what that one is. The total score is at least 11, then that means the probability that the red is 6 and the blue is 5, blue is 5, or the red is 5 and the blue is 6, or they're both 6. Red 6, blue 6. Okay? And I'm going to come look at this. This one is the red 6 and blue 5. Those both have to be true. Those both have to be true. And those both have to be true. Right? So when I'm looking at the total of at least 11, then the AND statements, I'm going to do what? I'm going to multiply. 1/6, that red 6, and 1/6, blue 5. The OR statement, I'm going to add red 5 and blue 6. The OR statement is the add, and this is 1/6 times 1/6. So you're really getting 1/36 plus 1/36 plus 1/36 is equal to, wow, actually it comes out to 3/36, which is equal to 1/12. Okay, do you get the idea of how you can combine? And I think if you get this idea of the AND and the OR statements, and being multiplying or being add, that will help a lot. Okay, here's the last one. And this one's a little bit more challenging. So let me get this one going. It says the diagram above shows 2 spinners. The first spinner, the scores 1, 2, and 3 are equally likely. And for the second spinner, 1, 2, 3, and 4 are equally likely. So they're fair spinners. Both pointers will be spun. Writing your answers as fractions in lowest terms, find the probability of each event. So if you have the 2 spinners, the scores in the 2 spinners is equal to 2. Okay, well, let's look at this. It's equal to 2. Okay, if I picked a 1 here, to make it 2, it would have to be a 1 over here. So I'm going to say, well, that would be that spinner 1 is a 1 and spinner 2 is a 1. That would work. Okay, if I picked a 2 here, it's not going to work. 3 here, it's not going to work. Those are the only things that will work. And when I have an and statement, I am going to multiply. Okay, if I pick, this one's 1 out of 3, and this one is 1 out of 4 is my probability. 3 possible outcomes, 4 possible outcomes. That probability is 1/12. Okay, now if I want the total of the scores on the 2 spinners is 3. To make that happen, so my total is 3. Okay, I'd have to have a 1 on the first one and a 2 on the other one. That would work. Plus, let's see, I could have a probability of 2 on the first one and a 1 on the second one. And that's it. So these are and statements. Both of these have to be true. So I'm going to multiply 1/3 times 1/4. But then this statement right here, this is a or statement. One of these has to be true, so I'm going to say add. And I'm going to have again 1/3 times 1/4. So this one's 1/12 plus 1/12, 2/12, I get 1/6. Okay, what about the total of the scores from the 2 spinners is 5. Whew, that's going to be a lot. Let's see. Well, I could have 1 and 4, or, I'm saying it's an or, I could have, let's see, let's try, how about 2 and 3, or I could have 3 and 2, or, let's see, couldn't I do, let's see, total, I could have 1 and 4, 2 and 3, 3 and 2. Okay, and what about if I did it in a different order? A different order would mean that if I spun a 4 over here, if I did a 1, nope, that's still a 1 and a 4. That's it. Those are all the different possible combinations to make it 5. So again, I'm going to do 1/3 and 1/4 plus 1/3 and 1/4 plus 1/3 and 1/4. Okay, now I'm going to get 3 over 12, which is equal to 1/4. Okay, let's try this one. The total of the scores in the 2 spinners is not 5. That's a complement. So if I know what the total of the scores is equal to 5, well, let's see. We already figured that out. If it's equal to 5, we already said, let's see, the total is equal to 5. Total of scores is equal to 1/4 up here, right? So I could just say 1 minus 1/4 because it's the complement, and I'm going to get 3/4. Does that help? I hope. Let me go to see if there's anything else. Okay. So what I want you to make sure when you define independent and disjoint events or mutually exclusive, there are 2 events, they're independent, and knowing that one event has occurred does not change the probability that the other event has occurred. Or 2 events are said to be disjoint if they have no outcomes in common. So we talked about the addition rule, okay, which is an and statement, okay. I'm sorry, not an and statement. It's an or statement, but you use the and statement at the end because you're going to subtract off that intersection. The addition rule can be used in conjunction with the multiplication rule for independent events. Okay, so if and only if the probability of A and B is equal to probability of A times the probability of B. Two events are said to be disjoint if they have no outcomes in common. And the addition rule for disjoint events can be used in conjunction with the multiplication rule for independent events. That's what we covered in this lesson. So good luck with the lesson. I don't think it's too bad. And then you have a really easy one for lesson 2. And then next week we're going to work on what you would have seen for a test. Okay, good luck.